Hey guys, this is going to be a quick little show you how to do percent by mass problems. So in any formula or molecule or formula unit or any sort of compound, what you have is you have a certain number of each particular type of atom that's together, and it's a specific ratio. So this right here is what's known as glucose. So glucose has to have 6 carbons, 12 hydrogens, and 6 oxygens. It has to. It has to have that ratio of 1 to 2 to 2. So this is or 1 to 2 to 1, sorry. And so this is a very specific ratio that in every single compound we have the law of definite proportions, which says we have to have those proportions for each individual compound. And so, of course, each of these weighs a certain amount. And so we know from the periodic table that carbon, for example, weighs 12 grams per mole. So in 1 mole of carbon, it is going to weigh 12 grams, right? And so hydrogen, the same way. If you're to weigh out hydrogen, you just need to weigh out 1 gram of hydrogen, and that's a whole mole. So hydrogen is very small. And then oxygen is 16 grams per mole. So oxygen is clearly the heaviest of these three, but what we can see is that each of these have different masses and different amounts. So even though there's 6 carbons and 6 oxygens, oxygen is going to have a little bit more mass than carbon. And even though there's 12 hydrogens, its mass isn't going to even compare to the mass of the other two. So percent by mass is going to have to take into calculation the actual weight of each of these molecules. And so it's really simple to do. All you got to do is add up the total mass of the compound. So in this right here, this compound, what you're going to have is 6 carbons, each weighing 12 grams. So that's going to be 12 times 6, so you got 72 grams of carbon, right? And over here we have 12 grams of hydrogen, each weighing 1 gram. So here we have 12 grams of hydrogen. And over here we have 6 grams of oxygen, each weighing 16. So that's going to be 96 grams of oxygen. Okay? So then what you need to do is you need to add up the total of this, because to get a percentage, like if you're trying to figure out the percentage you got on a test, what would you do? You would do the total of your correct answers, right, divided by the total possible. And it's the same thing here. We're doing percent, and that's kind of what you do. You have a overall thing that everything is out of, and then you have the amount that you have that you're looking for the percent of. So all you have to do for percent by mass, and here's the formula right here. So percent mass of any compound is going to equal the mass of the element divided by the mass of the compound, right, times 100. All right, so let's just put this in. Pretty simple. So we know that, let's see, plus 72 plus 12. I'm just figuring out the total here. So the total, if we add this all up, is 180, because that's 72 plus 12 plus 96. So we have 180. Okay, so 72 divided by 180 is going to give us 0.4 times 100 is going to give us 40% carbon, right? And let's do this one. Let's go ahead and look at 12. So we have the mass of the compound, or the mass of the element, which is 12 grams, divided by the mass of the whole compound, which is 180. So 12 divided by 180 is going to give me 6.7%. Okay, and I multiplied that times 100 as well. So here we go. So then 96 divided by 180 times 100 is going to give me 53% here. So there you go. Make sure you label these. So 63% hydrogen, 40% carbon, and 53% oxygen. There's your percent by mass. So piece of cake. All you got to do is add up each individual element, add up the total, and take the amount of each element divided by the total, multiply by 100, and there you go. You'll end up with your percent by mass. And so that will give you an idea of how much of each element by mass do you have a percentage of. So clearly oxygen is the heaviest, and so even though you have the most hydrogens, it's actually the smallest amount of the mass because hydrogen is a small atom. All right, hopefully that helps and helps you get a lot of answers correct on your chemistry.